Hello everyone, how are you? Today I'm going to talk about statistical hypothesis testing and the errors that we make in the statistical tests. So let's first start with what is hypothesis. So a hypothesis is a statement, and most commonly it is based on inference or existing literature or preliminary studies that postulates that a difference exists between groups. Suppose between groups like smoker versus non-smoker, or exposed versus non-exposed, male versus female, so different type of groups, and the possibility that this difference occurs by chance is tested using statistical procedures. So statistical procedures are the test that validates the postulates or validates the hypothesis, or actually show that the hypothesis is, if the hypothesis is correct or if it is wrong. So the statistical hypotheses are mainly two types. So one is null hypothesis and another is alternate hypothesis. Null hypothesis, or H, null, is hypothesis of no or null difference or no relationship between the disease and the risk factor, or between two groups. So there is no association between the disease and the risk factor. So the main important take-home message from null hypothesis is it tells you that there is no difference between groups. So that's the null hypothesis. And alternate hypothesis is the opposite of null hypothesis. And this hypothesis is about telling you that there is some difference or some relationship. Suppose there is some association between the disease and the risk factor in the population. So there is some difference between two groups. So here is a chart, or here is a table, 2x2 table, to show you the statistical power and errors. So in the upper panel we have the reality, and in the lower panel we have the study result. So the reality can be a gold standard. Suppose we have a gold standard test, and the study results are a study that we are comparing with the gold standard. So gold standard is the 100% true test. So the gold standard can tell that there is actually a difference or there is actually no difference. So the gold standard can be either alternate hypothesis or can be null hypothesis. And the study results can be also two types. So one study result can be that it can tell you that there is actually a difference between two population groups, or there is actually association between a risk and an exposure, risk and a disease. And it can also tell you the null hypothesis, or it can also prove the null hypothesis that there is no association between a risk factor and disease, or there is no difference between groups. So this actually creates four type of situations. So the first situation is when in reality there is actually a difference between two groups, or there is actually an association between risk factor and disease. So when the reality shows that there is the alternative hypothesis is really true, and the study result also correspond with this H1, which is alternate hypothesis, now it becomes the power, which is called statistical power, measured as 1 minus beta. And another situation is when in reality there is a difference between study population, but the study actually fails to show the difference between study groups, and this results in an error which is called type 2 error or beta. So in case of type 2 error, there is actually a difference between two groups, but the study actually fails to show the difference. So the study was blind to the difference that was actually present. And another situation is when in reality there is no difference between two groups, or null difference, but the study shows that there is actually a difference between groups. So the study saw something which was not there. So this creates another type of error, which is called alpha error or type 1 error. Another type of situation is when in reality there is no relationship between the risk factor and disease, or there is no difference between two groups, and the study also tells the same thing. So there is no difference between two groups, or there is no relationship between the exposure or between the risk and disease. And this is one type of correct study. So this is very important. This is a very important chart to actually have a good concept on, because you will use it in different type of situations. So there can be multiple types of outcome of statistical hypothesis testing, and one of the result is correct result. So correct result can be two types. So one is stating that there is an effect or there is an difference when one exists. So here you reject the null hypothesis, which null hypothesis means it tells you that there is no difference, and you accept the alternative hypothesis. In another way of telling it is that stating there is not an effect or difference when none exists. This is also a correct result. So here you tell that null hypothesis is not rejected, because it is in reality it's true. So there is no difference in reality, and the test also tells you that there is no difference. So this is another kind of correct result. So as I have already mentioned, correct result can be two types. One is when there is a difference, the study also tells that there is a difference. So the study accepts the alternate hypothesis. Another is the study tells you there is no difference. In reality there is no difference, and the study tells you that null hypothesis should not be rejected, null hypothesis should be accepted. So incorrect results can be of two types, like the correct results. So one is type 1 error, which is also known as alpha, and another is type 2 error, also known as beta. So the type 1 error is stating that there is an effect or there is a difference when none exists. In another way of expression is null hypothesis is rejected, meaning that you actually tell that there is a difference, there is something. So you are rejecting the null hypothesis, and the fact that is actually not right. So null hypothesis is rejected, although it is true. Although there is no difference, you are telling, the test is telling that no, there is some difference. So alpha is the probability of making a type 1 error, and P is the chance of type 1 error occurring. So P is judged against a preset alpha level of significance, usually 0.05, less than 0.05, which is very important. So if P is less than 0.05, or P is also known as probability value, if probability value is less than 0.05, then there is less than 5% chance that the data will show something, or data will show a type 1 error and show something that is not really there. So the chance of making a type 1 error is 5%. And therefore p value equal to or less than 0.05 is generally considered statistically significant, because the chance of doing a type 1 error is very low here, as low as 5%. And type 1 error is also known as a false positive error, because the test tell that it is positive, or the test tell that there is a difference which is positive, but in reality it is false. So that's why it's called a false positive error. And one way of remembering it is alpha A. So you saw a difference that really didn't exist, like convicting an innocent man. And type 1 error is commonly found in low specific test, which gives you high false positives, increasing the type 1 error. This is a very important concept to remember. Another type of error is type 2 error. So in type 2 error, you state that, or the test state that there is no effect or difference when one exists. So there is actually a difference in reality, but the test says that, or the test tells that no, there is no difference. So here null hypothesis is not rejected, although it is false. I mean, those are tough words to memorize, but just remember the concept. So here null hypothesis means that there is no difference, and the tests tell there is no difference, but in reality there is difference. So the test is in favor of null hypothesis, but in reality alternate hypothesis is correct, but the test was failed to identify alternate hypothesis. Test was along the line of null hypothesis. So this is the type 2 error. Type 2 error is also known as false negative error. Why? Because the type 2 results, in type 2 error, the test comes out as negative, or the test tells that there is no difference. No difference means negative, but it's false because there is actually some difference. So that's why it's called a false negative error. So beta is the probability of making a type 2 error, And for remember purpose, I brought it from first aid. Beta is equals to you are blind to the truth. So you didn't see something which was there. You didn't see the truth. You falsified it. So that is type 2 error. Another important consideration is statistical power, which is calculated as 1 minus beta. So it is the probability of rejecting the null hypothesis when it is false. It's a bit tough to understand the first time for me too. So what does it mean? Rejecting the null hypothesis, meaning that telling that there is no difference. It's telling that there is no difference when one exists, when actually there is alternate hypothesis which is positive. So rejecting null hypothesis meaning you are rejecting null hypothesis. What does it mean? You are accepting alternate hypothesis, and that's right. That is statistical power. So telling there is a difference when there is a difference is called statistical power. So it's the ability to detect a difference in groups if it is truly there. So I think rather than remembering that, you should remember that. It's easier words to actually remember. And in case of type 2 error, you can increase power and decrease beta or type 2 error by increasing sample size. When you increase the sample size, the power increases, so the statistical significance increases, and the level of type 2 error decreases. And you increase expected effect size, also increases power. Increase precision of measurement, also increases power and decreases beta or type 2 error. So one take-home message is, if you increase sample size, you increase power, and there is power in numbers. Another important concept to actually remember is very important, which is Pearson correlation coefficient. So Pearson correlation coefficient is also expressed as R. So R is typically or always between -1 to +1. The closer the absolute value of R to 1, the stronger the linear correlation between two variables. The positive R value states you that there is positive correlation, meaning that if one variable increase, the other variable also increase, and vice versa. Negative R value tells you negative correlation. As one variable increase, the other variable also will be in reverse, or other variable will decrease. And coefficient of determination is R square, value that is usually reported. So here I have a case for you. Inflammatory biological markers are clinically useful in a number of different ways, including assessment of disease activity in conditions such as SLE. A new inflammatory marker is being studied. When the blood level of the new marker is measured along with the C-reactive protein level, the following plot is obtained. So here you have a plot. Those are called scatter diagram. So here is a new marker and here is a CRP. Based on the plot, the correlation coefficient between two variables is closest to, so there are multiple types of numbers, 2 positive, 2 negative, and 1 0. So here what do you see here? So we can actually see multiple points, multiple dots. So those dots are each the graph plots. So as you can see, this higher area represents the high level of new marker, which corresponds to a low level of CRP. And in contrast, suppose this marker, this point represents a low level of new marker and a high level of CRP. So as you can see that there is an actual inverse relationship between new marker and the CRP. So when new marker is high, the CRP level is low. When new marker level is low, the CRP level is high. So there is an inverse relationship. So we have to find out our answer, or Pearson correlation coefficient between -0.2 and -0.8. Though among those two, one would be answer. And as you can see that there is some degree of linear relationship between those two, and that's why it should be as close to 1. So the answer should be -0.0. So this is our answer for the scatter diagram. Thanks for watching my video, and please keep me in your prayers.